Hey everybody, today we're going to practice some of what we did in the previous lesson, the surface area and volume 1 lesson, and then we're going to move on to bring in a couple of new figures that will require some new tricks. So we're going to do a little bit of review first, and then we're going to go from there. All right, so we're going to start with a pentagonal prism. Now you probably don't hear that phrase much, but a pentagonal prism is what you get when you take a pentagon on top, a pentagon on bottom, and then you've got rectangles down the sides connecting them. So pentagon on top, pentagon on bottom, and then the sides. If you want to know the surface area, you have to start with the two bases and then work your way around. Now, if you ever wonder what to call the base is whatever there are two of that run parallel to each other. So in the case of this example, it's a pentagon. In the case of the next example, it's actually the triangles because you have this triangle here and this triangle here. They run side by side. There are two of them. So the bases are the triangles. Then when you get to the third problem, and we talked about this before, about how the best way to handle the third problem is just to think of it as two circles, and then they sort of wrap around and become almost like a division symbol there. Because if you think about it like a can of tuna fish here, you have a label, and the label has to make it all the way around the circles. So anyway, so let's go back. Now that we know what the bases are, let's figure out the area of them. The area of a regular polygon is 1/2 AP. So in this case, it is a regular pentagon. The apothem is given to you. It's 3.4. The perimeter, well, you've got 5 sides, and they're each 5. So 5 times 5, or you could just put 25 if you want to just cut to the chase. Throw that in a calculator, and you end up getting 42.5 centimeters squared. Now, there are two of them. There is a hexagon on top. There is also a hexagon, or a pentagon, I'm sorry. There's a pentagon on top. There is also a pentagon on bottom. So you have to take that number and multiply it by 2. So you end up getting 2 times 42.5, which equals 85 centimeters squared. All right, now you go to the lateral area. That would be the sides. Lateral is just all of those sides that are wrapping around. In this case, the lateral area, it looks to me like what I have here are 5 by 11 rectangles. That's really all I see here. It's 5 by 11 rectangles. So you've got 1 and then 2, 3, 4, 5. So all we really need to do is just think in terms of 5 times 11, which would be 55 centimeters squared. And then there are going to be 5 of them. So we'll do 5 times 55, which would be 275 centimeters squared. The total area is just what you get from both bases plus what you get from the sides, which would be 275 plus 85, which would be 360 centimeters squared. Now, you are not given formulas on the end of course exam, but if at some point you might want them, the surface area shortcut would be 2b plus the perimeter times the height. Now, this is where people get thrown off. What in the world? Why are we using big B? Big B, whenever you see a formula that involves big B, that's referring to the area of the entire base. It's not referring to like a two-dimensional, like a triangle being 1/2 base times height. We're talking about a 3-dimensional figure, and that big B is the area of the entire base. So in this example, big B would be that number right there. Okay, so that's where people get thrown off a little bit. Let's try it again. I think we'll get better at it. And again, I don't even use the shortcuts. I don't even use the formulas, but some people do, so I wanted to present it here. All right, so let's take a look at this next one here. So we've got ourselves a triangle. The area of a triangle is 1/2 base times height. So that's going to be 1/2 times 12 times 9. Notice we're doing little b, so we're just talking about the base of the triangle. We're not talking about the entire triangle itself. 12 times 9 is 108. Half of 108 is 54 square inches. So that is the area of just the base. Now, there are two of them. There's a triangle in front and there's a triangle in back, which means the entire base area is 108 square inches. Now, this one is a little bit trickier when we talk about lateral area. There are three faces that wrap around the triangles. It's kind of hard to visualize, so I'll just have to color code it the best I can. You've got this top face. You've got this side here, and then you've got the bottom. So one of them is going to be a 9 by 10, which is going to be 90. One of them is going to be a 12 by 10, which is 120. And the top face is actually not as easy to figure out because we don't actually know this length right here. We don't know the hypotenuse of this triangle. The good news is it's a right triangle, so we could do a little bit of work on the side and figure it out. So we should probably do that. 9 squared plus 12 squared equals c squared. So we're just going to throw that in on the side. And if you were to do 9 squared plus 12 squared on a calculator, you get 225. It seems like this is going nowhere here, but 225 is actually a perfect square. And it turns out this missing side length is actually 15 inches. So let's go back to what we just talked about. We have a rectangle over here that has an area of 90. We have a rectangle on bottom that has an area of 12 times 10, 120. And now we have this top face, which is 15 times 10, which is 150. So the lateral area is those three put together. 90 plus 150 plus 120, which would be 360 square inches. The total area would be all of those put together. The 108 and the 360 put together, which would be 468. And the shortcut, once again, if you're into that sort of thing, it's the same idea. If you take two bases and then you do the perimeter of the triangle times the height, you would get what you're looking for. Again, I'm not a fan of it. I'm just putting it there to help if that's something that you would like help with. All right, let's do the cylinder. Now this one's a little bit tougher for a lot of people. We know that the diameter is 10. That means the radius is 5. So that's a good start anyway. Now, we also know that the height of this cylinder is 2. So think about it like a hockey puck. We've got to flip it back down. This is on its side currently. We need to flip it down so that the circle is on the ground. So depending on how you're thinking of it, it's important to look at it like that. Now, the part that people always mess up as far as dimensions are concerned is figuring out how long the label has to be to make it all the way around the circle. So basically, if we were to flatten this out and figure out the area, how long would this rectangle be? And it turns out it has to be, like I said, long enough to make it around the circle. And whenever you're going around a circle, the measurement we're thinking of here is circumference. So if the diameter is 10, that means the circumference is 10 pi. So that's that missing measurement. Now, the base area times 2, the base is the circle. Area of a circle is pi r squared. So if we're going to do pi times 5 squared, and I'm just going to leave it in terms of pi. I think that's going to be the easiest way to go. 25 times pi, I'm just going to put 25 pi. And then I'm going to put 25 pi again. And then this rectangle is 10 pi times 2. 10 times 2 is 20. So let's go through and let's see what we came up with. The base area times 2 would be 2 times 25 pi. Sorry, there's no pi shortcut over here. Which would come out to 50 pi centimeters squared. I'm just going to leave it like that. You could get the decimal. I'm not really in the mood. Lateral area, we already figured it out, which is good. It's just that rectangle. I've had a lot of students in the past be like, well, really, that was it? They were expecting it to be worse. 20 pi centimeters squared. And then that means the total area would be 50 pi plus 20 pi, which would be 70 pi centimeters squared. Now, what's interesting about the shortcut for this one, and I've seen it written, you get 2b plus, and then the way I've seen it written in a textbook is 2 pi RH, which is actually the same shortcut as what we did before. It's just instead of doing perimeter, we're doing circumference, and circumference is 2 pi r. So it really does make sense. You just have to think about it. All right, so pause this video here if you need another second, and we will move on to the next part. All right, so now we're talking about some new figures. And when we're talking about a pyramid, your surface area idea is going to be the same. This one's going to be a square pyramid. The only difference is now we need to consider this measurement up here, this 12. That right there is called a slant height. And the way it is labeled in math is with a curly, like cursive L. Not sure why they do it. Long story. But we need to make sure we don't get it confused for the regular height. And here's why we have to do this. If you were to flatten out this pyramid, what you would find out is that you basically have a square and then 4 triangles. So if you can figure out the area of the square, which is actually really easy, you have what you need. So the area of the square, 6 times 6 is 36. And then you've got to start working your way through the triangles. There are 4 of them. Each one of them has a base of 6 and a height of 12. So that would be, if you were to look and do 1/2 base times height. So 1/2 of 6 times 12. Half of 6 is 3. 3 times 12 is 36. So it actually turns out all 5 of these measurements are 36. Now, obviously, my drawing is not to scale. If you're wondering, well, that can't be 36. It looks smaller. Well, the real triangles were much taller. That's why it worked out that they were the same. 36 times 5 is 180 centimeters squared. The key was knowing that slant height, which unfortunately you're not always going to know, like in the case of this last figure of the day, which is a cone. Now, I told you everything is based on the slant height, and we don't know the slant height. However, if we are given a problem where we know the radius and the regular height, then we can figure it out. Now, one other thing that I think we should do, we're introducing cones here for the first time. I think it would probably be good if we turn it around. So I'm going to do that. I flipped it on my paper. Now we might have a little bit better of a perspective for going through the rest of the problem. So again, if we're missing the slant height, we should probably do the Pythagorean theorem to work it out. And that's what we're going to do here. This one works out pretty well. If c squared is 100, then that means the slant height is 10. Again, what number squared is 100? We're going to use 10. And that is your slant height. Now, when you're doing surface area here, we're going to have to do the base, which is a circle. So that's one of the things we're going to do first. The area is pi r squared. R is 6. 6 squared is 36. So that would give you an area of 36 pi square feet. And now this is where I really hate doing this, but I'm going to have to. If you were to draw the net of a cone, what you would actually get and I'm just warning you, it's not going to be pretty. What you would actually get would be one circle, and then you'd get another circle, but you'd have something cut out of it. That's actually what we talked about on the very first lesson of the year. We started talking about what would happen. And the reason that has to happen is because you have to be able to take this bottom part and wrap it around. Not easy to do. So I bring that up because I don't like teaching with formulas. But in this particular case, the only other option is working with that net, and you really don't want to go there. So I'm just going to cut to the chase. Surface area of a cone is base plus pi r slant height. Now, this is really cheesy, but I think of this as pi r l, so I think of it as base plus purl. P-I-R-L. Base plus purl. Really cheesy, just go with it. It's fine. We already know that the base was 25 pi. So our shortcut is actually going to be valuable here because now we're going to do the radius and then the slant height. And what we end up getting here is 25 pi plus 60 pi, which would give you 85 pi square feet. And again, you could use a decimal on your calculator if you wanted to. I'm just going to leave it in terms of pi so that I don't have to. So again, I don't like teaching, hey, here's the formula, memorize it, but I'm just going to tell you right now, that's one that you have to memorize. You don't really have a lot of better options. I mean, you do. You could probably find something else where you could draw it out. I just think you're going to be a lot better off if you just memorize base plus purl. All right, so now we have ourselves a square pyramid. We have ourselves a cone. And that should hopefully get us on our way to understand the rest of surface area. Thanks for watching. I'll see you next time.